All right, in this video, we want to prove these trig identities over here. And I think all of them are double angle ones. So, well, not all, but most. Let's get started with the first one over here. So in this one, the left side is more complicated because we have a minus here. So even though this is a double angle one, we want to work on the left side here. Now, if I have cot to theta, I want to use my trig identities to kind of simplify that. And I'm basically going to use my double angle tan identity, which is tan 2 theta equals to 2 tan theta over 1 minus tan square theta, which means if I want cot to theta, I'm just going to flip this one upside down, which is 1 minus tan square theta over 2 tan theta. So I want to basically turn the left side of the equation into something similar like this over here. So let's look at the left side over here. Normally we convert cot and tan into sine and cos, but if I look at the entire question here, there's no sine, cos, or anything related to sine, cos everywhere. So instead of converting to sine and cos, I'm going to convert the cot into 1 over tan theta. Then I'm going to make a common denominator here. So I'm going to multiply the top and bottom here by tan theta, which means I'll get 1 minus tan square theta. Now I have a common denominator of tan theta. And now if I look, it's pretty similar to this. The only thing missing over here is this 2. So what I'm going to do is I'm going to multiply a 2 on the top and a 2 on the bottom, because these 2's can cancel and it doesn't change the equation at all. So now I can replace this whole thing over here with this equation of cot 2 theta. So I'm just left with this 2 and then cot 2 theta. And now it matches the right side of the equation, which means I've proved this trig identity. Let's go to the second question over here. This one is pretty similar. The only difference is now we have a cosec over here. But you want to use similar logic. The reciprocal of cosec is sine, and we know that sine 2 theta is 2 sine theta cos theta. That's our double angle identity for sine, which means that cosec 2 theta is going to be 1 over 2 sine theta cos theta. So now I want to get rid of this cot and this tan, but now I'm going to convert it to sine and cos because we're basically related to sine and cos on the other side. So I'm going to turn the cot into cos theta over sine theta. I'm going to turn the tan into cos theta over, sine theta over cos theta. Next, I'm going to make a common denominator. So I'm going to multiply sine on the top and bottom here and cos on the top and bottom here. So here I'll get cos square theta plus sine square theta. And now I have a common denominator of sine theta, cos theta. Next, I know that cos square plus sine square is just 1 by my Pythagorean identity. And now if I compare this to this, again, it's pretty similar. The only thing missing is the 2. And we just have to multiply a 2 on the top and a 2 on the bottom. And basically, I'm going to replace 1 over 2 sine theta cos theta with cosec 2 theta. So I'm just left with 2 cosec 2 theta, which matches the other side. And I've proved this trig identity as well. All right, let's go to the third and fourth question this video. This one here is just using my addition formula for tan. This one's a pretty simple one. Just going to use the formula tan a plus b equals to tan a plus tan b divided by 1 minus tan a tan b, the addition formula or the compound angle formula for tan. So pretty simple, just working on this right side over here. It's going to be tan x plus tan pi over 4 divided by 1 minus tan x tan pi over 4. Now, using your special triangles or your calculator, you should know that tan pi over 4 is just 1. Oops, no, it's just a 1. And then tan x plus 1 is the same as 1 plus tan x. I'm just going to rearrange it so it looks exactly like the left side. So I have 1 plus tan x over tan x times 1 is just tan x. So that's just 1 minus tan x. And now it matches the left side. So I proved this third trig identity as well. Let's go to the last question over here, fourth question over here. This one again is pretty similar to the one we did earlier. So the left side is definitely more complicated. So we want to work on the left side for this one. We have cosec and we have cot, and then we want to turn it into just a regular cot. So these are double angles. I know that cosec is 1 over sine. So I'll start by just changing that to 1 over sine 2x. And cot, I will turn that into cos over sine. The reason why I picked that instead of turning it into a tan is so that I have a common denominator. But again, there could be multiple ways to solve this question. So a lot of different possibilities on how you could solve it. Now I'm just going to combine these. 1 plus cos 2x divided by, oops, common denominators sine 2x. So now I'll replace cos 2x with, there's 3 different formulas for cos 2x, but I'm going to specifically pick 2 cos square x minus 1. And the reason why I'm picking that one is because this 1 and that minus 1 will cancel off. So I'm going to replace the cos 2x with 2 cos square x minus 1. And I picked this formula because this 1 and this negative 1 will cancel in the next step. But even if you pick any of the other ones, eventually you will get the same answer. It just might be 1 or 2 steps longer. Sine 2x, we only have one choice, which is to replace it with 2 sine x cos x. Next step, this one and this one cancel. So we're just left with 2 cos square x divided by 2 sine x cos x. These 2's will cancel. Cos x will cancel with the square. I'm just left with cos x over sine x, which is basically cot x, which matches the other side. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.